Hello everyone, I welcome all of you again to the series of Work and Time. I hope you are enjoying the series and learning a lot, right? Okay, so in the previous lectures we have discussed the type of question in work and time, that is efficiency of individuals, right? We have discussed efficiency of individual and we have also seen a formula work equal to efficiency into time. In today's lecture we will address a new type of concept or new type of question, and the type we will be calling it group of people working together. So first type of question which we have seen in work and time, that is efficiency of individual. How do we identify that? When we see that individuals are mentioned, A can do a piece of work, B can do a piece of work, A and B together can do a piece of work. Whereas in this type of question you will see that we have 10 people working together, 15 women working together, 5 boys working together. So there is a group of people and we have to assume that they are having same efficiency. So group of people working together. So let's see how to handle these kind of questions. Now, as we have seen the concept, we have seen the formula. What is the formula? Work equal to efficiency into time. Yeah, work equal to efficiency into time. We also tried to remember that formula or relationship between work, efficiency and time like this. So if I want to find time equal to, so I'll hide time, then I have work divided by efficiency. If I want to find efficiency equal to, so I hide efficiency, then I have work upon time. If I want to find work equal to, then I hide work and then I have efficiency into time. All right. So this is the same formula which we are going to use for this concept also. Now let's try to solve this question and see how do we do it. Okay, so here it says 10 men can complete a piece of work in 15 days. Fine. 15 women can complete the same work in 12 days. All right. If all the 5 men and 10 women, or let me say, this all is not making sense. If 5 men and 10 women working together, then in how many days will the work be completed? Okay. Now group of people working together. So first what do? We assume let efficiency of a man here equal to M and efficiency of a woman equal to W. Okay, so we assume efficiency of each one of them. Now we go as per the question. The question said 10 men 15 days to complete the work. So here I'll say work equal to 10 M will be the efficiency. 10 M will be the efficiency of one man is M. So efficiency of 10 men will be 10 M, right? Multiply by time. What is the time given? 15 days. Are you okay with this first equation? Yes? Very good. Let's see the second equation. What is the second condition? And 15 women can complete the same work in 12 days. The same work. 15 women are able to complete in what? 12 days. That's your equation number 2. I hope so far so good. We assume the efficiency of each one of them and then we go as per the question condition, right? Now these two conditions are given. What do we need to find? What do we need to find? We need to find if 5 men and 10 women are working together. If 5 men and 10 women are working together, then in how many days will they complete the work specific to that? That means same work. So here in this case work will be equal to, now what is the total efficiency? Think about it. Efficiency of 5 men and efficiency of 10 women. If you add, because they are working together, right? So total efficiency here should be 5m plus 10W. That's total efficiency, right? Multiply by time. That's we need to find out. And I will call this to be equation number 3. Yeah, if you're directly jumping on this video, then I request you please go through the video number 1 and 2 of the previous video of work and time. That will get you clarity of what am I doing here, okay? And if you have done that, I'm sure you will understand this. You are understanding this. Yeah, assuming work. So we have not assumed work as any number or LCM. Yeah, we are addressing different type of question. What type is that? What is this type called? It's called when group of people working together. Group of people working together. Previously, which type have we addressed? Efficiency of individuals. Yeah, when individual people name mention. Okay. Clear? Now you got 3 equations. You need to simplify. Okay. So by now all these 3 equations, the left hand side same amount of work. Left hand side you have same amount of work. So you can equate them. You can equate them, right? You can equate them. How do you equate? You can say by equation 1 and 2. By equation 1 and 2. If left hand side is equal, right hand side is also equal. Yeah. We are understanding, we are learning the fundamental of this new type here. So I am writing all the steps. But you know, when I'm going to solve in the exam, or even when you are going to solve in the exam, you don't have to write all the steps. Okay. And removing more and more steps, skipping more and more steps will become shortcut. Yeah. Okay. Anyways, so if you equate both of them, 10m into 15 equal to 15w into 12. Yeah, because left hand side are equal. Left hand sides are equal. Okay, for both. Simplify them. 15 cancel, and then I can say m. I take 10 to the other side and w here this side. So m by w will be equal to 12 by 10. I mean, maximum what you can do, you can simplify this further. You can say 6 upon 5, cancel by 5, right? So by doing so, here you got the ratio of their efficiency. By the way, what is the unit of efficiency? I have discussed in the previous lecture. What is the unit of efficiency? Tell me. What is the unit of efficiency for this particular chapter? Correct. The unit of efficiency. The unit of efficiency is units of work per unit time. So time unit is what? Days. So per unit time. So unit of work per day. That's the unit of efficiency in the topic work and time. Okay. I mean, this is what I mean by efficiency. How much work a person can do in one day, or unit time, 1 hour, 1 minute, whatever time is mentioned. All right. Now you got ratio of m upon w as 6 upon 5. Now I can assume numerator and numerator same and denominator same. See, I can assume that to make solution look little easy and shorter. Yeah. Although if m upon w ratio is 6 upon 5, I cannot directly say that m equal to 6 and w equal to 5, because ratio does not reflect the actual value. Ratio does not reflect the actual value. We have learned this in ratio chapter, right? In the ratio chapter. But in this case, to have the shortcut, once you have ratio of efficiency, you can assume that m equal to 6 and w equal to 5. The numerator 6, numerator same, and denominator equal. Okay, because otherwise, what is the assuming method? What is the assuming method in ratio? The assuming method says, if I want to assume them as something like m upon w is ratioing 6 is to 5, so I can assume them as 6x and 5x. So I have to take a common multiple with both of them. Yeah. Now, why am I advising you to don't worry about this? Why am I advising you to not be bothered about it? Because I know even if I take the multiple constant here and simplify it further, that is going to eventually get cancelled. Okay. So that's why we are assuming numerator equal, denominator equal. Okay, and we have done this kind of assumption in profit and loss chapter also. Yeah, I'm giving you a lot of references. Well, so now what to do? Okay, so I assume this. Yeah, now here is this t which what we need to find out. Here this t which value we need to find out, right? So I have to take third equation, because this is the equation where I need to find the value of t. But to equate this left hand side, I can choose either one of the equation, first or second, either one of the equation of first or second. That's your call. Whichever you are finding it easy, you can take that. For now, let's take equation number 3, because I need to find out time, and equation number 1, where we have work equal to 10m into 15. Why am I taking both equations? Because I again see left hand sides are equal. So I can equate both of them and say 5m plus 10w into t equal to 10m into 15. So it will look like what? 5m plus 10w into t equal to 10m into, what was that? 15, correct. 10m into 15. Now I will substitute the value of m as 6 and w as 5, which I have got from which I have got by solving the equation number 1 and 2, right? So substitute value here, m equal to 6, w equal to 5, time we need to find out, m equal to 6 and 15 as it is. Simplify further, this is 30, this is 50, 30 plus 50 is 80t. Here you go, I'm not big fan of calculation. We can do the calculation later at the end when we are having all the numbers together, and the only step remaining now is simplifying. Now you do the calculation. Now you can do the calculation. 0 0 cancel here, right? 30, 50, 80, and then I got 6 here, 5 here. Absolutely right. I'm just checking. Okay, simplify further. You got 3s are, you got 4s are. So this is 45 by 4, which we can say 22.5 half is 11.25. That will be your answer. 11.25 days. That will be your answer. Okay. Now the next question we have 15 men takes 20 days to complete a job working 8 hours a day. So tell me, first of all, tell me here, what is the time in the given in first condition? What is the time given in the first condition? 15 men takes 20 days to complete a job working 8 hours per day. What is the time what is time given here? Is it 20 days or 8 hours? See, whenever you get such kind of condition, I mean both are time, so you convert them into the smaller unit. Here you have 20 days and 8 hours a day, 8 hours in one day. So smaller unit is hours in this case, right? Smaller unit is hours in this case. So here I will say the work equal to efficiency into time. Yeah. By using the same, I will say work equal to efficiency. Now 15 men. Now see, assuming the efficiency, let's say each man efficiency is M, right? So I can say 15 men efficiency is 15 M, right? Now time given, no, combine both, time given, combine both. You got 20 days and 8 hours each days, right? 8 hours each days. That means total time for which this 15 men are working, that is 20 into 8 hours. So that means 160 hours, right? Okay. So this entire thing is time. This entire thing is time. Are you getting it? 20 days they are working and each day they are working for 8 hours. So 8 into 20 will be total time. Okay. In hours, right? Now you got the same work. You got the same work. Which the number of hours a day should be worked. So number of hours per day, that's not given. But this time you got 20 men working for 12 days. Hours not given. So we need to find out hours in this case. Equation number 1, equation number 2. So first of all, tell me, are you comfortable making this equation? Any difficulty here? Assume the efficiency of men. You don't have to write that again here. Come on. Efficiency of men as man as M, each man as M. Yeah, let's take their initials, no, initial of the word. That become much easier to identify. Instead of assuming X, Y, Z, P, Q, R, some random variable, let's take initials of the word. So for men, so for 15 men, for each man I can take efficiency to be M. Yeah. Now equate both of them, left hand side is equal. So I hope you are finding something common in such kind of questions. Yeah. When group of people are working together, you're finding the work left hand side having same all the time. Yeah. Now I need to find out H. To find out H, I can say 15M into 20 into 8 divided by 20M into 12. Yeah. Now let's simplify this. So simplification, M cancel, 20 cancel, 4 2s are 4 3s are 3 5s are 15. So 5 2s are 10. So how many days, how many hours per day they need to work? They need to work 10 hours per day. That's your answer. Any question, confusion? Perfect. Okay. Look at the next question. Look at the next question. I want you to pause this video here. Pause this video here. Look at the question. Try answering by yourself. Okay. By now you are quite comfortable with ratio and work and time concept. Quite comfortable with ratio and work and time concept. Okay. So let's see, what do we have here? 12 men, 16 boys and 16 boys. That means together. Okay. Can do a piece of work in 5 days working, which 13 men and 24 boys can complete in 4 days. Find the ratio of the daily work done by a man to that of a boy. A man to that of a boy. daily work done. What is daily work done in this case should be called? Daily work done. That means work, daily work. So how will I write it? I will write it work per day. Is it not sounding familiar to you? Work per day, that's nothing but the efficiency. That's nothing but the efficiency. So question is trying to ask you, find the ratio of efficiency. A ratio of work done per day, that means ratio of efficiency of a man to that of a boy. If I assume the efficiency of a man is M and efficiency of a boy to be B, what do I need to find? I need to find M upon B, and this should be pretty easy for you, isn't it? Now let's take the first condition, which says 12 men plus 16 boys, they take 5 days to complete a job which 13 men, see, I can make equation number 1, equation number 2, but you understand. Now let's skip steps to make solution look smaller, so you will feel like we are doing shortcut, we are solving in shortcut, right? Yeah, that's what people do, man. Like I have seen most of the institutes, they say it's shortcut, but ultimately that's skipping of some steps, that's it. So yeah, so 12 men plus 16 boys into time, efficiency into time is equal to work. Now same work, so can I say this is also work? Yeah, it's not division, huh? This is also work, and that is equal to another work which is done by 15 men and 24 boys. 13 men and 24 boys into how many days? 4 days. So this is also amount of work and this is also amount of work, right? And question said both work are equal. It says in 5 days, which 13 men and 25 days can complete in 4 days. Which is for what? Which is for that is giving the reference of the work done in the previous condition. So work by them and work by these people, this group. Work by this group and work by this group. Both of them are doing equal amount of work. So we put it equal between them. Are you okay with this equation? Yes, no. See, I have done the same thing. Work equal to this, and then equate both of them. So I am skipping these two, writing these two equations and directly jumping on making the work equal, right? Great. Okay, come back. We need to find out M upon B. Now show some magic of simplifying equation. So here you got 60M plus 80B equal to 52M plus 96B, right? Now I take M one side and B other side. Always shift smaller value. Remember, always shift smaller value. That will not put you in the confusion of negative, positive. Okay, so whenever you find the smaller value and if you have to shift, if you change the side, so you have two options. You can change 60M or you can change the side of 52M. Select the smaller value and change side of the smaller value. 60M minus 52M will give you what? 8M. 96B minus 80B will get you what? 16B. I hope you are comfortable with this, guys. I am not interested writing one more step, changing side and then put the minus sign and then write this equation. Solving equation. I hope you are able to handle this. These are easy one. And no worries. I mean, after arithmetic topics, we are going to jump to algebra. That's where we'll be discussing solving equations in detail. Okay. M and I take B to the other side. So m upon b is equal to 16 upon 8, which is nothing but what? 2 by 1, 2 is to 1. Yes, 2 is to 1. Yes, 2 is to 1. Yeah. Okay. So this is your answer. I hope people who paused the video and then tried solving the question, I'm sure you must have got the similar answer. And look at this question. So here we have two trains, one 200 meters long and traveling with 60 kilometers per hour. Another train 250 meters long and traveling at 42 kilometers per hour. Here they are moving in the parallel track in the same direction. Okay. How long does it take for the faster train to completely overtake the slower one? How long does it take for the faster one to completely overtake the slower one? Now, overtake will happen only when the faster one is behind the slower one, correct? तो मैं ऐसा आपको डायग्राम बना के बताता हूँ. And so let's say this is a faster train. Let's say this is 200 meters. How much? 200 meters. And the slower one, now when we look at, when we deal with such kind of question where we talk about overtaking or something, we assume that the head, and this is tail, and this is head, and this is tail. So we assume the head of the object which is behind is in the same axis as the tail of the object which is ahead. Okay, so there is no gap between that until and unless it is given in the question. So if it is not given in the question, this is what we need to consider. अगर क्वेश्चन में नहीं दिया है तो हमें ऐसा अज्यूम करना है. ओके, ये मान के चलो. नाउ मूविंग इन द सेम डायरेक्शन. ठीक है, सेम डायरेक्शन में देखते हैं. अच्छा, पहले का स्पीड कितना? 60 किलोमीटर्स पर आवर. द फास्टर वन इज 60 किलोमीटर्स पर आवर and the slower one is what? 42 kilometers per hour. Okay, now they are moving in the same direction. What are we going to apply? We are going to apply relative speed to understand the speed. अब यहाँ पे आप टाइम कैसे सेव कर सकते हो? डोंट कन्वर्ट दिस. अच्छा, कन्वर्जन करना ये आपको पता है ना, बिकॉज स्पीड यूनिट इज गिवन इन किलोमीटर्स पर आवर एंड द डिस्टेंस इज इन मीटर्स. सो वी हैव टू कन्वर्ट either one of them, and it is advisable to convert kilometer per hour into meter per second, because ये जो 200 और 150 ये 1000 से बहुत छोटा है. 1000 मतलब 1 किलोमीटर, 1000 मीटर मतलब 1 किलोमीटर, राइट? So it is advisable to convert these speeds into from kilometer per hour to meter per second. Now how can you save time? What I was saying, that how can you save time here? यहाँ पे यूजुअली स्टूडेंट्स क्या करते हैं? पहले स्पीड को कन्वर्ट करते हैं, बाद में रिलेटिव स्पीड से डील करते हैं. आई हैव अ डिफरेंट ओपिनियन हियर. आई सजेस्ट कीप द कैलकुलेशन एट लास्ट. जितना कैलकुलेशन को आप आगे बढ़ा सकते हो उतना आगे बढ़ाओ, बहुत अच्छा होगा, आपको अच्छा फील होगा उससे. देखो यहाँ पे 60 किलोमीटर्स पर आवर है, 42 किलोमीटर्स पर आवर. नाउ इफ़ यू सी द रिलेटिव स्पीड हियर, रिलेटिव स्पीड ऑफ द ट्रेन्स, रिलेटिव स्पीड्स ऑफ द ट्रेन, रिलेटिव स्पीड ऑफ ट्रेन्स, it will be 60 minus 42. 60 minus 42 कितना होगा? 18 watt kilometer per hour. ठीक है. Now if you convert that into meter per second, what is the fraction you multiply with? 5 by 18. That will convert into meter per second. See, this is the benefit of doing this. आपको एग्जाम में कोई कैलकुलेशन, आप कितने फास्ट कैलकुलेशन में हो, कितना हार्ड कैलकुलेशन कर सकते हो, nobody is going to check that. You are answering एग्जाम विच इज़ मोर ऑफ एप्टीट्यूड. एप्टीट्यूड मतलब आप अप्लाई कितना अच्छे से कर सकते हो, कॉन्सेप्ट्स को कितने अच्छे से अप्लाई कर सकते हो. दैट इज व्हाट दे आर गोइंग टू चेक हियर. सो कैलकुलेशन मोस्टली कैलकुलेशन ईजी होंगे. नाउ हियर यू गॉट 5 मीटर पर सेकेंड एज द रिलेटिव स्पीड. वेल, व्हेन वी टॉक अबाउट ट्रेन्स and overtake or cross in either one of the situation, if you remember, I told you that लेंथ ऑफ ट्रेन इज पार्ट ऑफ डिस्टेंस. लेंथ ऑफ ट्रेन इज पार्ट ऑफ डिस्टेंस. यहाँ पे लेंथ ऑफ ट्रेन कितना है? 200, 150. बताओ लेंथ ऑफ ट्रेन कितना होगा? 200 प्लस 150 कितना होगा? लेंथ ऑफ ट्रेन इज 350. दिस इज योर डिस्टेंस, राइट? व्हाट you want to calculate to find the time. to overtake, the faster one to overtake the slower one. So time will be equal to distance, which is 350, with relative speed, which is 5 meter per second. This is meter and this is meter per second. देखो units बराबर है, units ठीक है, meter and meter per second. Simplify कर दो, कितना हो जाएगा? 70 seconds. Time is in seconds. So time in such cases 70 seconds. Clear? Easy है, easy है, easy होगा. अभी तो concept questions ही चल रहे हैं, अभी solved examples चल रहे हैं. When we solve practice sets, once we come on the practice set, then questions will be difficult. So this is it in today's video. My name is Shyam Manawat signing off. I will see you in the next lecture of work and time, and we will learn the next concept, that is negative work, in the next lecture. All right. Till then, stay happy, stay healthy. Bye bye.